Hi guys, welcome back. In this video, we're going to be discussing why the elasticity, guys, the price elasticity of demand varies along the average revenue or the demand curve, right? We know that the average revenue is your demand curve. Now, what you can see over here is that you have a linear sloping downward demand curve, which is your average revenue curve. Now, if you've seen my previous video on the revenue in imperfect markets, I've told you that the average revenue curve, you must not, uh, you know, touch the quantity intercept. When you're drawing the average revenue curve, there's no need to touch the quantity intercept. And I gave you the example that the simple reason is that your average revenue will never be zero because your price will never be zero. So a monopolist will never charge a zero price. But right now I have, so for AS students, if you're just drawing a demand curve, I mean, that's not a big problem. And even if you touch the quantity intercept, that's not a problem. But at A2 level, especially if you're even if you're drawing a general demand curve and you touch it to the quantity axis, it's not a problem. But especially when you're drawing an average revenue curve for a monopolist, right? Since demand curve is your average revenue curve in imperfect markets, they both correspond on the same line. So the average revenue will never be zero because a monopoly will not charge a zero price. Anyways, but for the sake of this video, we have touched it on the quantity intersect because I wanted to mathematically show you certain points on, at, for example, on the quantity axis, you have a PD equals to zero, right? So for that sake, so you have a downward sloping demand curve here, and we can see that, the price elasticity of demand at this point at the top is, infinite. The PED value is infinite, while at the bottom on the extreme and on the price intercept it's infinite, while on the quantity intercept, on the x-intercept, it's the value of PED equals 0 at this point. And in the middle, the PED is actually, sorry, the PED is, just a second, the PED is equals to 1 over here. That is, it is unitary elastic, right? So the value of PED equals to 1. Now, and in this range, the PED is basically elastic, while in this range along the demand curve, the PED is inelastic. So as you go, what we learn is that as you go along the demand curve, as you go down along a linear demand curve, is going to be, first of all, the linear demand curve, downward sloping demand curve is showing us different regions. So basically all these are different regions of elasticity along the demand curve. So this is a region where the demand is elastic, while this is a region where demand is inelastic, right? And in this video, we're going to learn why. Now, as far as the AS students are concerned, they must also have learned this thing in AS level as well, that, this is, I mean, as you go down the demand curve, your elasticity goes down. But in this video, I'm going to be telling you why does it goes down actually. And there's a mathematical reason or arithmetic reason behind it. So first of all, points on the top part of the demand curve on the topmost region are elastic, while at the bottom we find that the demand curve, the points on the demand curve tends to be inelastic. Now the formula for PD is the percentage change in quantity demanded divided by the percentage change in price. We know that, right? Now the thing is, guys, since elasticity involves calculating the percentage changes, right? So there is a general property of percentage changes, an arithmetic property that, and we should know that as economic students so that we can actually judge why is elasticity going down. Although you're not supposed to know this in your exam, but I feel like if you know this, you will definitely have an upper edge. So, the thing is that the property says that, the value or the extent or the size of the percentage change actually depends upon the initial point or the starting point of the, on whom you're calculating or to whom or from where you're calculating the percentage change. So now what this means is, just hang on. What this means is that, for example, if I take an example where I say that, let's say my income is, or my earnings are currently, let's say $10,000. So my starting point is $10,000 and that is my initial income. And let's say my company gives me a raise of, it goes up by $10,000. So my income raises by $10,000 and it moves to $20,000. Now, if I were to ask you to calculate the percentage change, you will calculate it by the formula. You'll say that, we'll take change in income divided by the original income times 100. That's how you calculate percentage changes, right? It's change upon original times 100 or change upon initial. So my initial income in this case is 10,000, while my change in income is also 10,000 as it's going up by 10,000. So 10,000 divided by 10,000 times 100 would give me, 10,000 over 10,000 times 100 would give me how much? Would give me 100% rise. So the percentage change in income is basically 100%, plus 100% showing that, my income is going up by 100%, right? So And so if my income goes up by 10,000, I see that so there's a 100% increase in my income. Now let's take another scenario. Let's take a scenario where I say that my starting income or my initial income, instead of being 10,000, my initial income is, let's say, instead of 10,000, it is 100,000. So let's say I'm earning $100,000 and my income goes up by the same amount, that is 10,000. So here as well, my income was going up by 10,000. Here also my income was going up by 10,000, right? So again, and now my income is 110,000 per month, right? $110,000 per month. If I were to calculate the percentage change now, and I'll be like, okay, fine, calculate the percentage change. So you'll be like, okay, fine, change in income divided by original. So the change in income is 10,000, while the initial or the original is 100,000. Divide by 100,000 times 100, and this would give me a value of 10%. So my income in this case, I mean my percentage increase in income is 10%. So you can see, you can compare both scenarios, that in both the scenarios my income was going up by 10,000 over here and over here as well. But this is representing, in the first case it is representing 100% increase in income, while the second case is representing only a 10% increase in income. Although my income is going up by the same amount, but the percentage increase in income is differing. One is going up by 100, the other is going up by relatively quite less. So what we conclude from this arithmetic calculation is that we can say that there's a property which says that, or there's a rule or arithmetic rule which says that when our numbers or variables are lower, when our numbers or variables are at a lower levels, initial numbers or initial variables are at a lower levels relative to the change, so the percentage change would always be large. So for example, if our numbers, like I said, if our numbers or variables are at a lower level as compared to the change, here the change and the initial level is the same, but let's say if this was, let's say, 9k or 8k, even then the percentage change would have been much higher, in fact more than 100% in this case. So, and conversely, on the other hand, when my number or variable is quite high, let's say 100,000 relative to the change, so change is 10,000 while the initial number or the original number is 100,000. So the number or the variable, the original number of variable is quite high relative to the change, which is 10,000. So when I was earning 100k, then my percentage increase in income comes out as small, that is only 10%, right? So what we conclude is that if my starting level is relatively higher, or if my original is relatively, if the original is relatively high, right? If the original is relatively higher, so remember that we will always have, if the original is higher, this is higher relative to the change in income, right? We will always have a small percentage change. So the percentage change will always be small as compared to a situation when the starting point of the original is relatively low relative to the change. So the change is high. I mean, the change is the whatever the change is, whether it's high or low, we're not thinking that, but relative to the change, as in if the original value is lower as compared to the change, then the percentage change would always be, the percentage change would always have a larger value. Just like if the original was $10,000 and the percentage increase was 100%, while if the original was a higher value as compared to the change, which was only 10,000, the percentage increase was 10,000, right? Was 10%. Now what we're going to be doing is that the same arithmetic logic or the same arithmetic rule, we're going to apply this. So what we do is that now we'll apply the same logic and reasoning to our demand curve, and we will apply this to our demand curve and the elasticity formula. And now let's see what we can derive out of it. So guys, if you see that I have drawn a demand curve over here, right, and I have reduced the price from P1 to P2, and the quantity is going up from Q1 to Q2. Now there are 2 to 3 important things that you need to know. First of all, as the price is going down, but the original price or the initial price is P1. Also remember that since this is the middle point, let's say, so this is the middle point, so over here the value of PD is equal to 1 unitary elastic, and in this range, this is the elastic range of the demand curve where the value of PD is greater than 1, right? And in this elastic range, let's say we are taking a starting point P1 and then we're reducing it to P2 now. So first of all, guys, P1 is, we can see that P1 is quite a high price. So P1 is quite a high price. High price as in the value is quite high. So if you're reducing price from P1 to P2 and P1 is quite a high price, and why is it a high price? Because if we imagine all the possible prices that could possibly charged, in this range, then compared to that prices, P1 is quite high. But on the other hand, if you see that all the quantities, that possible quantities that could be consumed along the demand curve, Q1 is quite low, right? If you think of all the possible quantities that could be consumed, right? So the price falls from, if the price goes down from, if the price falls from P1 to P2, then the percentage fall in price in this case would be quite low. Why? Because the starting point of the price fall is quite high. The original price is quite high. So remember, the formula would be the change in price divided by the original price times 100, right? So since the original price would be quite high, applying it relative to the change in price would be quite high relative to the change in price. Mathematically, the value would be low. Mathematically, the percentage change would be low, right? And if you calculate the percentage change in quantity from an increase from Q1 to Q2, since Q1 is quite low, the original value is quite low. So if you calculate the increase in, if the quantity is going up, you calculate the percentage increase in quantity, then that would be quite high, because the same arithmetic rule will apply that if you're calculating percentage changes and the original value or the initial starting point is quite low, then definitely the percentage change would be high. So the change in quantity divided by the original quantity times 100. So if the original quantity is low as compared to the change in quantity relative to the change in quantity or comparative to the change in quantity, then the percentage change will be quite high. Now, as you know, the formula for PD is percentage change in QT divided by the percentage change in price. Now we have a combination where the percentage change in price is low while the percentage change in quantity is high. So if you have a combination, now listen to this very carefully, if you have a combination of a large percentage change in quantity, large percentage change in quantity, if this value is high while this value is low relative to the percentage change in quantity, so if you have a combination of a large percentage change in quantity with a small percentage change in price, so automatically the value of PD, would be greater than 1, right? So the thing is that the value of PD would be greater than 1 in this case, right? So the thing is that the PD would be greater than 1 in terms of the coefficient value, because we are dividing by a larger percentage change by in quantity divided by a larger percentage change in price. But you see, as you go down the demand curve, your price goes down, and your price in this region, as we are saying that this is the inelastic region. The reason why this is the inelastic region is because here your prices are quite low, right? Let's say here your prices are quite low, right? Here your prices are quite low while your quantity demanded is quite high relative to the all the possible quantities. So the price is low, let's say P3, P4, this is quantity is Q3, Q4. So over here, if there's a percentage decrease in price from P3 to P4, we already know that P3 is quite low relative to the other prices, right? And the quantity on the other hand is quite Q3. If the quantity goes up from Q3 to Q4, then quantity Q3 is already, quite high. So the thing is that in this region, we'll see that the value of PD would automatically come to less than 1. So we can see that the value of PD in this region, guys, would be inelastic as compared to so it's compared to the PD values in this region where, the PD values would be elastic greater than 1. And the simple reason is that in this region where the PD is elastic, the prices are quite high relatively here as compared to relative to the prices over here, right? So if there's a percentage decrease in price over here in this region, in this region where the demand is inelastic, in this region, let's say, in this entire region, the value of the price is quite low. And since the value of the price is quite low, if you calculate the percentage change in price, whether the price is going up or down, but since you are dividing a number by a low denominator, right? Because the percentage change formula is change divided by original times 100. So you're dividing a low value, right? Because P3, let's say, would be the original price. So P3 would be a lower value. You're dividing the denominator original of a lower value, right? So the percentage change has to be higher in this case. And if the percentage change is quite high, let's say over here, if you plug in the percentage change in price in the elasticity formula, and the percentage change in price is quite higher, which makes your denominator quite higher, so arithmetically the value of PD would be quite low, in this case less than 1, and that's what inelastic demand is, if the value of PD is inelastic. So if we sort of, see this example, um, we know that, like I said, it's giving the exact opposite result in the region where PD is greater than 1 versus in the region where PD is less than 1. So just a small quick brief recap, that the price P3 is a low price while the quantity Q3 is a high price, right, relative to all the other possible prices and quantities. So since P3 is quite low while Q3 is quite high, right, so applying the same arithmetic logic of percentage changes, since our quantity Q3 is quite high, so we see a rise in quantity from Q3 to Q4. So that rise, the percentage increase or the percentage rise, will result in a smaller value from Q3 to Q4, the percentage increase. Because like I said, the percentage increase is the change divided by change in quantity divided by the original quantity. And since the original quantity Q3 is quite high, so the denominator is quite high, which would arithmetically give a lower percentage change. And applying to the PD formula, if PD is percentage change in quantity demanded divided by the percentage change in price, so if the percentage change in quantity demanded is low, right, versus the percentage change in price would be quite high, then automatic the value of the PD would be low, right? In our case less than 1. So guys, as we know that the value P3, the price P3 is already quite low, which is the original price going to P4 now. So in this region where PD is inelastic, the prices are comparatively quite low as compared to the prices in the elastic region. What happens is that the movement in the prices in this region would result in percentage change in prices to be quite high. And if you apply it in the PD formula, if the percentage change in price is high while the percentage change in quantity demanded is low, so combination of this would result in a lower PD value of less than 1, where the coefficient of PD would be less than 1, right? Because the denominator over here would be more than the numerator. So automatically and arithmetically will result in those conditions that are required for PD to be inelastic. So guys, what we conclude is that, as if this is our linear sloping demand curve, right? And you see, if we go down the demand curve, if the demand extends, right, and the prices keep on falling, if the prices keep on falling and the quantities that are being demanded and sold just keep on rising, so what happens is that as we're moving down the demand curve and we increase our quantity that is demanded, followed by a reduction in prices, since that's indicating consumer behavior. So what happens is that our PD is gradually falling. So our PD gradually falls. Now, a fall in PD simply means that from elastic it becomes inelastic. It transitions from elasticity that is being, so if the coefficient in this region, let's say in this region, because over here the PD would be equal to 1, in this region is elastic, let's say 3 or 4 or 5. So slowly and gradually it would keep on falling unless it becomes inelastic. And the further down the curve it goes, the further inelastic it becomes. And the reason why further inelastic has become has to do with price, because the percentage change in prices in this region would result in higher values, because in this region, if you're calculating the percentage change in prices, then the percentage change in price would always result in a higher value, because the original price, because the percentage change, the change is always from a value that is an original value, right? So if you take any of these prices as the original price, so that is going to represent a smaller value, and if the original value is smaller, then the percentage change has to be higher. So if the percentage change in price is higher, the PD would always be lower, because the denominator in the PD formula would always be higher than the numerator, resulting in a lower PD value each time as you just keep on going down the demand curve. And so the actual logic is that the price is falling. So as you're decreasing the price, the PD gradually decreases, it becomes less elastic, and then it ultimately becomes inelastic. And so you see, at the price axis or the y-intercept, if this is your y-intercept, at the y-intercept or the price intercept, at this point the PD is perfectly elastic. That is, PD is equals to infinity, right? And as you're increasing the quantity, our elasticity is reducing in absolute value. So the coefficient of elasticity goes down. And it becomes less elastic, since our price is decreasing and our quantity is increasing. So both the factors are playing a role. So the price is going down while the quantity is going up. This is the reason. And price going down, quantity going up. And mathematically, what that does is, like I've already explained what that does. Arithmetically, what's the logic behind it, right? And in the middle, the PD equals to 1, right? And at the quantity axis intercept, or the y-intercept, sorry, the x-intercept, the PD is perfectly inelastic, that is equals to 0. Because we have reached, the reason why it's equal to 0 is because we've reached the maximum quantity that we can sell. So any further price changes here won't lead to any further increases in demand. And the demand is completely non-responsive to a price change, right? In the middle, the PD is unitary elastic, that is equal to 1. So these are the ranges or the regions. So you must know this, that the value of PD goes down as you go down the demand curve. Important thing you need to know is that since PD goes down along a downward sloping demand curve, and we know that in imperfect markets, monopolies, oligopolies, or monopolistic competitive markets, they have a downward sloping demand curve, right? And if they have a downward sloping demand curve, then firms in imperfect markets, if they reduce the price, then they will have different impacts on total revenues. And the reason why they will have different impacts on total revenues each time is because elasticity of demand differs along a linear downward sloping demand curve, right? So if you reduce the price in the elastic region, total revenue goes up. While you reduce the price in the inelastic region, the total revenue goes down. And for that explanation, for that analysis, you need to wait for my next video. I'll cover that in my next video. Thank you so much, guys, for watching this video. I'll see you all around in the next video. Until then, take care.